So tonight's messing about in the shop is ably assisted by Juice of the Beans Oatmeal Stout, Coffee Oatmeal Stout from Oxus Brewing Company in Winnipeg. It's basically their Juice of the Oats Oatmeal Stout paired with Peruvian organic coffee roasted by Sheepdog Brewing Company. Oh yeah, that'll keep me awake all night and give me a bit of a buzz. Awesome. So tonight I am checking out this new Unity UT658 dual USB tester that I got in the last mailbag. It seems like a reasonable thing. Well, I mean, Unity is a relatively well-known brand, so that's likely going to lead to it being trustworthy. On the back, it says it can take an input anywhere from 4 volts up to 24 volts and up to 3 amps on the USB-A connector, or up to 5 amps on the USB-C connector. And it can measure or record, I guess, up to, is that 5 nines? 99,999 milliamp hours. If you're interested in recording how much current goes into a particular thing that you're charging, that's nice. Then on the back here, we have the inputs coming from that side and the outputs going to that side. So the input can either be the Type A or Type C USB, and output the same there. However, reading in the manual, it says it only goes Type C to Type C or Type A to Type A. You can't use this to convert from one to the other. So that's, it is what it is. I mean, they make converting adapters, so that's not a big deal. Let's look at the, oh, hang on, missed something. That's important. So, I guess we should maybe plug it into power just so we can see what the screen says. I'll just plug it into a power bank for now just to look at the voltages and whatnot. So on the screen we have a voltage DC, we have current in amps, we have milliamp hours and elapsed time. When we go to mode, we can get watt hours. We can get the equivalent impedance or resistance of the load. Basically, that's just calculated from the voltage and the current. And then we can get the voltage that's on the 2 data pins. So when you're plugged into a load and charger that are communicating over the data pins and setting a voltage via a voltage divider or something, then we can see what that is. And then back into the main screen here. And you can see that it is aware that it's using the USB-A right now. I'm just going to plug it into something awkward here for a minute. Pay no attention to that. But now you can see that it's using the USB-C and it's showing 4.98 volts, which is coming from my power supply here. So there's a little bit of a voltage drop through the cabling and whatnot. Or one of these is not accurate. I'll have to figure that out in a minute here. So I think before we go too deep into using and testing this thing, might as well see what's inside it. That's always fun. Now then, how does that open? Ah, there we go. Blob chip. That's disappointing. Though I suppose El Blobo is not really surprising. So just the 2 resistive buttons on the front. Okay, and the screen. Okay, so I didn't need to unscrew the screen. I think I will actually screw that back on before I get too carried away here. But that is good that the screen is, screwed on in its little bezel there so that the zebra stripe doesn't get dislodged and nothing gets damaged or anything. Speaking of damaged. No, it still works. Okay. There's the 2 inputs. There's the USB-A and the USB-C input. USB-C input's actually got heavier gauge wires in there for the voltage, so that is nice. And then the data pins go down there, and USB-A, the data pins go down there. Those are, well, they're lighter than those, but they are heavier than the data wires. That's good. Anyway, so those go in here, and some fairly heavy tracks. Positives on this side, negatives on the other side. Okay. Ooh, is that wire kinked? Damaged or just... No, it's just a sharp bend. Okay, good. What are these components? Can't see, they're so tiny. We'll start with the obvious one, the current shunt resistor. So that's where the measurement is done across that resistor. And it looks like there's a potential for another one in parallel with it if you wanted to fine-tune that. That's nice. That looks like the frequency reference for the microcontroller, 32.768. So that and those two capacitors there will be the reference to that guy. Okay. SMBF 57082TG. So I just spent a bit of time trying to look up that part number and also the part number on several of these transistors and this little 5-pin component over here, and either my Google foo is really, really weak or these things are really obscure and I can't tell which is which. This thing over here, SVCKJ, no idea. I'm assuming those are a relatively common transistor of some sort, N7HG, but I can't find them. Oh, Y1, okay, that's a basic NPN. And there's more of those guys. I don't know. So here's how I'm going to test this guy. I'm going to use my little Ruideng load here. And I think we've determined before that it is quite accurate. But just for shits and giggles, I have added voltmeter leads onto the back of it so that we can go a little bit more precisely, because this thing only goes to 1 digit of precision in voltmeter mode. And this thing shows more than that. So let's get a meter out here. So we'll plug the load into there. I'm just going to do this with the USB-A right now, mostly because I don't have a power source with a USB-C on it. Stay tuned for a future mailbag where I will rectify that situation. But in the meantime, we'll just do it with USB-A. And just so that we know what we're dealing with, I'm going to use my my power supply here. So I don't think this thing reacts directly to the quick charge modes. I think it just displays whatever's going on. So we'll turn him on. I have this set for 1 amp. You can see it flickering away there. This is showing 1 amp. That's nice. That's showing 4.7 volts. That's showing 4.79, 4.8. That is showing 4.87. So that's fairly close, within a hundredth of a volt. No, within a few hundredths of a volt. So that's not bad. Over here, this thing is saying 5 volts. And it is saying 1.01 amps. That is saying 1.01 amps. And this is saying 1 amp. So those agree quite nicely. I'm happy with that. Let's just see what these other cheapies have to say for themselves, just for fun. No change to the power supply. It's still set to 5 volts and it's still showing 1 amp, so that's good. This thing is showing 4.7 volts though. This guy's showing 4.5 and that's showing 4.57. So it's got 0.3 of a volt drop through it. That's not, well, actually almost half a volt drop through it, so that's not performance. And it's showing 0.96 amps, so that's fairly close, but it's not great. I don't really like that that voltage drop through it. Then there's this ugly little thing here. So it's saying 4.83, 4.85 volts. It's showing 1.078 amps. And again, we've lost 0.4 of a volt through that. This is showing 4.5, 4.6 down there. It's not great. It's also losing voltage through it, and it's not as accurate or precise, and it's a pain in the ass to read. So let's see what happens if we crank the current up here. So there's 2 amps on this guy, and its fan is kicked in. That's also showing 2 amps, 4.6 volts, 4.56, so we are losing some voltage. Is that sagged down? No, that still says 5 volts there. I wonder what the actual voltage is right here. Just to make sure that this guy is, fully accurate. 4.95. Okay. So that's 4.95 there, 4.67 there. So we're losing, what, 0.3 of a volt here. And then, well, basically half a volt through this whole thing. Not ideal. But with a 2 amp draw, well, let's see what this guy has to say. It's showing that our load is an equivalent of 2.3 ohms. This thing said it could do 3 amps, so let's just see. So I think, yeah, this guy's currently running at 3 amps. 2.98 there, 3.03 here. Okay, 4.25, 4.3. It's really dropped off over here. But again, voltage drop across resistance, that's not really a big surprise, I guess. It's not ideal. It would be better if those conductors in there were a little bit heavier, but we're also going to be limited by the USB connectors as well. So let's crank this back down to 1 amp and try some higher voltages and see what happens. I think 8 volts is one of the quick charge voltages. So we'll try that. 1 amp. That says 1.01, 1.023. We had, what did I say? We had 8 volts there. This shows 7.81. That's 7.75. So that's fairly close. There's not that much drop between here and here. There's a little bit of drop in there again. What are some of the other quick charge voltages? Actually, hang on. Let me just try something different here. So now I've got my power supply connected to this quick charge module. So this thing will react to quick charge commands coming from my digital load. So I'll crank up my voltage over here to like 13 and a half. This thing is going to be doing some bucking to drop it down. So this ammeter all of a sudden is not indicative of what's happening over here, because this ammeter is showing at the higher voltage. We'd have to convert to watts for everything to be sane. But let's turn this guy on. So the load is set to do quick charge mode. It's right now that flashing. It's ordering quick charge 3. And we do have 12.07 volts coming out of the quick charge module, 1 amp, which is what this thing is set for. It's showing 12 volts. And the Kaiweets is showing 12 volts. Okay. And as you would expect, there is a lower current drop at the higher voltage, right? I squared R losses at higher voltage are going to be less. So that's one of the advantages of using quick charge in the higher voltages, is you don't get as much voltage loss over your charging cable. Let's just try this with a real world load. My phone. Now the Samsung phone doesn't charge at the full 12 volt quick charge, but we'll see what it does do here. So it has gone into its quick charging mode, which is 8.8 volts or 9 volts, I guess, realistically, and it's charging at about 1.5 amps, give or take. And yeah, the phone shows that it is on a fast charger and it's charging properly. It is interesting that its draw is kind of bouncing around a little bit. I wonder if that's kind of funkiness that the Samsung phone's doing. I'm not sure. I've never really observed it before. Anyway, that is just a real quick look at this Unity UT658 dual USB tester. I'm disappointed that I wasn't able to do the dual testing, but in a future mailbag I will have a USB-C capable charger and some other cabling and whatnot, so we'll be able to play with the USB-C side of this and actually make use of it. Again, now that I've got the capability, I might as well have the rest of it. Previously, that's all that I was able to test with, so I think I'm going to like this guy. It's definitely easier to read, which is a big plus. definitely don't get one of those. Those are horrible. This one's more okay than I thought, but it's still got more of a voltage loss through it than I like. This thing's still got a bit of a voltage loss through there. I suspect in the USB-C mode, because there is those heavier power cables in there, it's going to be a lot lower loss, but we'll have to see once the mailbag comes in. Anyway, thanks for watching. Questions, comments down below. I'll talk to you later.